Barker was giving me an eyeball today. He was like, he's staring me down in the hallway.
Today we have interpreting graphs of linear functions. A lot of your graphs, you have a line. When you have a line, you're going to have to find your slope. So try and find some points, find your rise, and find your run, and your slope, which equals m. We've also been referring to it as the rate of change equals your rise over your run. Okay. Look for your y-intercept. That's going to help you today to make your equation, because then you can put it into the format y equals mx plus b right away. So we're going to be looking at our graphs and finding that information and being able to then make a quick equation and answer more questions. As well, we then have to change into function notation. Okay. We'll talk about that as we go through. So let's have a look. A hot air balloon is flying at altitude of 1236. It descends. What's the opposite of descend?
Ascend.
Ascend. Does descend mean up or down? Down. Okay, and ascend means up. So at a rate of 10 meters per minute. Okay. So 10 meters per minute, that's the rate of change. What is the rate of change? Because 10 meters per minute is wrong. What do we have to do because of the word descend? Negative. Okay, negative 10 meters per minute. Right? And for the negative sign, right, you want to make sure you know for negative, it's going to be descend. Okay. Or decreases. That's the other word you got to watch out for. Okay. Now, without graphing, what are the intercepts? Well, one of them, we have the altitude of 1236. That's the beginning altitude. Because we're graphing altitude and not y, we call this just our vertical intercept. You'll notice in the textbook they do that. They'll say, what's the vertical intercept? And that's just because they're not using y, they're using altitude or h or something else. Okay? Good. So what we have here is we have the balloon descending by 10 meters per minute. So it's going to equal 123.6 minutes to touch the ground. 123.6 minutes. That's going to be your time, and that will be your horizontal or x intercept. So often, because we're not using the letter x, we're using something like t for time or s for second, something like that. They'll just refer to that as the horizontal intercept rather than simply x-intercept. So our variables, we've kind of described them already. We should do a depends on sentence. And so we can fill in time depends on altitude. That means up in the Himalayas where it's really high, time goes quicker. Is that true? And close to the ocean, time goes slower? No. Although we wish it would, right? Especially if it's Hawaii. It's the other way around. So the altitude of the balloon depends on the time. Okay. So your independent is time. Of course, that's your x. 99.999% of the time, time is independent. Your dependent is altitude. And that's your y, and this is the one that we have to measure. Okay. Good. So let's quickly graph it here. We have for vertical axis, we have 1236. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. So 1236 divided by 9 is what? 137.3. So what should we go up by? 50s wouldn't be enough. We have to go up by at least 137. Otherwise, we won't have enough squares. So how do we go up by 150 each one? Okay. So 150, 300, 450, 600. And then 1350 at the top. So this is our altitude, or H. Altitude will be measured in meters. What's a good title for this graph of a balloon descending? Oh, probably you are a genius. Descent of a balloon. Very descriptive, informative, but nice and short at the same time. Okay. Then time will be on our other axis. And what's time be measured in? Minutes. Okay. There you go. So, again, for time, 123.6 is our final value. And there's 9 squares. So that would be 13.7 per square. So what should we go up by? Nothing less than 13.7. Let's go up by 15s. Okay, we have 0, 0 as a start. So this is an easy graph because we only have 2 points. What's one of the points? 1,236. You're right. Way up here. Okay, now I'm just going to do approximately because we don't have to have a super accurate graph. So my vertical intercept is 1,236. My horizontal intercept is 123.6. So it's just going to be a little bit more than 120. Now I can go and make some straight lines. That's not what I wanted. Get out of here. That one. There we go. Okay. So a lot of graphs are going to look like this today, okay, as you're measuring. Right. So you have your intercepts. So state the domain or range in inequality interval notation. Indicate what each represents in this context. What is our domain representing? What's our time of? What's happening with the balloon? Our domain will be the time of the descent. Okay. What about our range? What's our range representing? The height of the balloon during the descent. Okay. Now this is a constant thing that's occurring. As an inequality, you always want to start like this. Okay, all inequalities you want to start with this. Then you put your low value on the left and our high value on the right. What's our low value for x? 0 times 0. What's our high value? 123.6. Okay. So then we have to write interval notation as well. What kind of brackets? Oh, for inequality, should we have the equal to sign part or not? Well, it can equal 0 at the beginning, and it can equal 120 at the end. So we must have the equal to sign. Yeah, you guys are making faces back and forth. That's why I moved you guys. Zoned out, did you? Okay. Interval notation. 0, 1, 2, 3 points. Where?
Hi.
What are you talking about? Can't you guys read? Okay, 0, 123.6. No, sometimes things just disappear off my pen if I press this button. It's true, actually, but it didn't happen that time. I'll admit it. 120. Okay, so next one. Height of the balloon. Can you please do it? Interval notation. As an inequality, what's the low value for y? 0 when the balloon touches the ground. What's the high value? 1236. Okay. Please put that into interval notation now, please. Go. The low value is 0. The high value is 1236. And you should be using square brackets because we can equal those values as well. Okay. Oh, did I? Thank you. Yeah, I am. Just seeing when I have my hair cut all that way here. Holy cow, that's ridiculous. Oh, wait, it's still there. Okay, write this relation in function notation. First of all, I want you to switch this, y equals mx plus b. Please write it using the information we know from up above. So replace your m and your b. Go. So what you should have written down was y equals negative 10x, because that's your rate of change, plus 1, 2, 3, 6. All that information's up here, folks. Okay. So here's your rate of change, and here's your intercept. Don't blame someone else. Come on, just because you're too lazy to think. Okay. Yeah. So now what you want to do is change your letters y and x, please. Change it to the letters that we're using. So what's our vertical letter? Altitude. And what's the other letter on the other axes? Time. Maybe we should use the letter. And so what goes in the brackets then? The letter T. Whatever variable you're using. That's totally stoned. Okay.
Is it actually?
Yeah, it is actually. Okay. Alright, so now that you have your equation in function notation, it's not really different than your y equals mx plus b. Just a little bit. Do I have to close the blinds?
No, it's like elementary school.
Yeah, yes, it is.
I love this. It's snowy.
Sorry.
It's gonna be 2 seconds.
I wasn't even this excited for some.
Oh yeah, what happened?
What's up?
Too damn cool.
Really? Oh yeah. Wait, where are we born? I know, but like where?
Okay, so just substitute and solve for the very last part. Any questions? Yeah. Okay, cell phone has a monthly fee of $20. That never changes. Every month you got to pay that. So that fee is constant. It doesn't change. However, for you typeaholics, type with your fingers, it's 15 cents for each text message for a number that's not on the favorites. Okay, so how would we, that's something that's repeating, right? One message is 15 cents, two messages it's 30, three messages it's 45. All right, you see what's going on here? That's right. So 0.15 times t. Write equation in function notation. So let's start with y equals mx plus b. We got y equals 0.15. That's our rate of change. And instead of x, let's use the letter t for text message, plus the constant monthly fee of $20 that'll never change. Now please change your equation to function notation. Remember, for your cell phone plan, we're trying to find the cost per month. So what letter would you use for y? You see? Good. C equals 0.15 t plus 20. There we go. Is that right? Or am I forgetting something? Yes, you got to make sure you use brackets and put the variable inside that you're using the other side of the equation. Okay? So C at T, the cost of the text messages. There we go. Good. So its monthly bill is $22.25. So what we're saying is C at T equals $22.25. Now work backwards to figure out how many text messages he sent. Work backwards. So 15, right? So he sent 15 texts to someone that's not on his favorite list.
I'm not doing anything.
Hey, come on. You're a little red. No, you're not. Okay. Now, is this data discrete or continuous? When you're finding out discrete or continuous, look at the information being graphed. We're talking about dollars, which is continuous because you have 0.1 cent, 2 cent, right? You have cents. What about the number of texts? Is that discrete or continuous? Discrete. And the reason why is because you only send one whole complete text messages. So texts are whole numbers. Absolutely, right? No one can send half a text message. You can send a garbage message because you can't type properly, or you press send too soon, but it's still one whole message that was sent. How would you indicate that on a graph? Well, for discrete data, you have to just have points, no line. But there's one exception. What is that? Unless you're graphing very large numbers. So if I had a graph and I was graphing this one 0, 1, 2, 3, I would put specific points on the graph. But if I was graphing 0, 100, 200, 300, well then I would probably put a line because it makes sense to have 150, 110, 101. There's all those points in between 100 and 200, so you should make a line. But even though you make a line, what kind of data is it? Still discrete. That does not change. Okay, once discrete, still discrete, always discrete, be discrete. Yeah, I know. Okay, so what would be the best way to express the domain and range of this relation? This is a little bit weird. We haven't done this. It's a little bit more than what we need to do for the quiz. But for your domain is your text messages. So it would be 0, 1, 2, 3 dot dot dot. So as an inequality, we could write it as, because the dot, what does the dot 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 mean? Yeah, the pattern continues. Okay? So another way of saying it is that x can be greater than or equal to 0, but must be whole numbers. So you sometimes, for inequality now, have to stipulate that it should be whole numbers. What about for your range? What are you starting at? What's your starting value for your range, your lowest value possible? Have a look at the graph. Or there's no graph, have a look at the equation. If you make 0 text messages, how much do you have to pay? $20. It's a little bit different, isn't it? So your lowest value for your range is 20. What if you send 1 text message? $20.15. 2 text messages? $20.30. 3 text messages? $20.45. Dot, dot, dot. Okay. So just get the first 3 or 4, show the pattern, and put dot, 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 and you're fine. Could you write that as an inequality as well? You could. You could say y is greater than or equal to $20, and you're going up by increments of 15 cents. Now, that's not the best answer. It's a little too wordy. I mean, just show the pattern. That's the best answer, okay? Is to just show that. That's best. And by best, I mean easiest for you guys. Any questions? Okay, let's continue on then. So Shays rate of pay is a direct variation relationship. So that's kind of like saying pay equals blank number of your pay times the hours. Okay? Compare that to pay equals like 1 over H, something like that. Now don't worry about direct variation, that's more old school, right? From the old math 10. Okay, so remember how she works. She makes works for 8 hours. Her pay is $92. So what's her rate of change? And this question is basically what's her wage? So she makes $92. That's going to be her vertical change. Her horizontal change will be 8 hours. So now you can figure out that she makes, what? What number should we write there? Go to your calculator, 92 divided by 8. Good. So if you write 11.5, I'm going to take off half a mark. Why? That's right. It's $11.50. I hope you're smarter than your calculator. Okay? So $11.50 per hour. Make sure you have 2 decimals for money. So the equation then would be pay equals $11.50 times hour. But it's not in function notation yet. It would be P, and what am I missing? I'm missing the variable in brackets. Okay, so P and H. Now what we can do is work backwards and figure out, substitute in 32 hours and solve. So P at 32 equals $11.50 times 32. $368. Okay, that's how much you get paid for 32 hours in a week. Okay. Any questions with that? Okay, so we love these ones with pay. Just a quick little, can you figure out how much you'd make, right? Next one, Mullet's rugby team purchases prizes. This graph shows the profit made from selling the raffle tickets. Underlying profit. Okay, it's important to know. N represents the number of tickets, and P represents the profit. Looking at the sentence of what's being graphed, is this data discrete or continuous? What would you say? Don't look at the graph, but look at what's being plotted. We have money. Is money discrete or continuous? It's continuous. And then we have raffle tickets. Discrete or continuous? Discrete. Okay. So tickets. Whoops. Tickets. And they are whole numbers. The lottery commission would not like it if you sold half a ticket. So why do you think though in our graph the points are joined? Why do we have this line then? Look at your numbers. Are you graphing 10 tickets? Or you're graphing 1,000 tickets. So they're joined because there's a large number of tickets being graphed. Okay. Good. So describe the domain and the range. What would be our domain? What would be our x value? What's the lowest number for our domain? Nope. 0. The lowest value is 0 for our domain. Okay. We're only able to sell 0 tickets. And then 1 ticket, 2 tickets, 3 tickets, 4 tickets, ... What would we do if we wrote that as an inequality? Please write that as an inequality. Make sure you stipulate the... I think I'm lost for the words. Okay. Make sure you mention the stipulation. There you go. So x is greater than or equal to be 0, but it must be whole numbers. Okay. What about your range? Your range, you know what? We need to figure out our slope first. Find our rate of change. We can't figure out our range until we know our rate of change. When you're doing your rate of change, you cannot use this point or this point or this point. You can use this one, and I would use this one. Those two would be the best options to find your rate of change. But you gotta be careful you don't use points that are not exactly on the line. So you can find your rise, be careful, it's not 1600. And find your run. So the rate of change is $3 per ticket. So for your domain, your starting value for your range, what would be your starting value, your lowest value? -800. Okay. Then what's the next value? -797. What's the next value? -794. ... So you're going up by $3 each ticket. Okay. Could you do an inequality? Yep. You could say y is greater than or equal to -800, increasing by multiples of 3. And that's just kind of a weird one, so you probably wouldn't list that as an inequality. You would just probably show your pattern ... Okay. Good. What I want you to do now is determine your profit at n. Okay. So use your rate of change and your intercept. We're trying to put it into slope-intercept form here. So y equals mx plus b, but we want to go straight into function notation. Okay. So p at n, our rate of change is 3, and our intercept is negative 800. It's that simple. Okay. So now we know that p at n is 4,000. And we can figure out how many tickets we have to sell in order to make that amount of profit. Okay, so must sell 1,600 tickets. The key today is to find your slope and find your intercepts. You'll need your slope to make your equation and also to find your domain and ranges. So you must find your slope, domain, and range. Okay. Homework, get started.